Hello everyone, welcome to E-Content Development Center, Majlis Arts and Science College, Puramannur. Myself, I am Shruti, Assistant Professor, PG Department of Mathematics. Today we are discuss about the concept of limit. This topic includes first semester BSc Complementary students under Calicut University. After watching this video, you will be able to understand the concept of limit, the properties of limit, and to solve problems related to this topic. Now we will start the simple definition of limit. The limit of f of x as x approaches a is L, and write limit extends to a f of x equal to L. That means x approaches to the point A, then the real valued function f of x approaches to the point L. Then the epsilon delta definition of limit is if limit extends to a f of x equal to L, if and only if given positive number epsilon, there exists a positive delta such that if 0 less than modulus of x minus a less than delta implies modulus of f of x minus L less than epsilon. Then we are discuss about the examples. First one, f of x equal to mod x. Mod x is defined as minus x if x less than 0, x if x greater than or equal to 0. The graph of the function mod x is given. F of x approaches arbitrarily close to 0 as x approaches 0. That means x approaches to 0, then the function modulus of x approaches to 0. That means the limit of f of x is 0 as x approaches to 0. Consider the unit step function u of x equal to 0 if x less than 0, 1 if x greater than or equal to 0. The value of u of x jump from x equal to 0 to 1 at 0. For negative values of x arbitrarily close to 0, u of x equal to 0. For positive values of x arbitrarily close to 0, u of x equal to 1. Here there is no single value L approached by u of x as x tends to 0. Therefore, unit step function has no limit at x equal to 0. Next we will discuss about some basic properties of limit. Let f and g have two real valued functions defined on some open interval containing x naught. The limit of f of x and g of x are exist. First one is sum rule. Limit extends to x naught f of x plus g of x equal to limit extends to x naught f of x plus limit extends to x naught g of x. Next one is product rule. Limit extends to x naught f of x into g of x equal to limit extends to x naught f of x into limit extends to x naught g of x. Then next one is reciprocal rule. Limit extends to x naught 1 by f of x naught can be written as 1 by limit extends to x naught f of x, provided if limit extends to x naught f of x not equal to 0. Next one is constant function rule. Limit extends to x naught c equal to c. C is a constant function. The next one, identity function rule. Limit extends to x naught x equal to x naught. Next one is replacement rule. If the functions f and g have the same values for all x near x naught but not necessarily including x equal to x naught, then limit extends to x naught f of x equal to limit extends to x naught g of x. Next we will discuss about the derived properties of limit. First one is extended sum rule. We are already discussed the sum rule of two variables. Here extended sum rule means the sum rule of n variables. That means limit extends to x naught f1 of x plus f2 of x plus etc plus fn of x equal to limit extends to x naught f1 of x plus limit extends to x naught f2 of x plus etc plus limit extends to x naught fn of x. The next one is extended product rule. Limit extends to x naught f1 of x into f2 of x into etc fn of x can be written as limit extends to x naught f1 of x into limit extends to x naught f2 of x into etc limit extends to x naught fn of x. Then next one is constant multiple rule. Limit extends to x naught c into f of x equal to c into limit extends to x naught f of x. C is a constant. Then next one is quotient rule. Quotient rule means limit x tends to x naught f of x by g of x equal to limit x tends to x naught f of x divided limit x tends to x naught g of x, provided if limit x tends to x naught g of x is not equal to 0. Then next one is power rule. Limit x tends to x naught x raised to n can be written as x naught all raised to n. Here n equal to 0 plus or minus 1 plus or minus 2 etc. and x naught not equal to n for n less than 0. Next we will discuss about problem. Use the basic and derived properties of limits to find the following limit. Limit x tends to 1 x cube minus 3x square plus 14x divided x raised to 6 plus x plus 1. Here we can use quotient rule. Then limit x tends to 1 x cube minus 3x square plus 14x divided x raised to 6 plus x plus 1 can be rewritten as limit x tends to 1 x cube minus 3x square plus 14x divided limit x tends to 1 x raised to 6 plus x plus 1. Then the value of limit x tends to 1 x cube minus 3x square plus 14x equal to limit x tends to 1 x cube plus limit x tends to 1 minus 3x square plus limit x tends to 1 14x using extended sum rule. Then equal to limit x tends to 1 x cube minus 3 is a constant, so minus 3 get outside, then minus 3 into limit x tends to 1 x square plus 14 is constant, then 14 is get outside, then 14 into limit x tends to 1 x equal to 1 cube minus 3 into 1 square plus 14 into 1. That means 1 is substituted in the value of x. Then final answer is 12. Then the value of limit x tends to 1 x raised to 6 minus x plus 1 equal to limit x tends to 1 x raised to 6 plus limit x tends to 1 x plus limit x tends to 1. Then 1 is a constant function, then 1 raised to 6 plus 1 plus 1, that's equal to 3. Since limit x tends to 1 x raised to 6 minus x plus 1 equal to 3 which is not equal to 0, then by quotient rule limit x tends to 1 x cube minus 3x square plus 14x divided x raised to 6 plus x plus 1 equal to limit x tends to 1 x cube minus 3x square plus 14x divided limit x tends to 1 x raised to 6 minus x plus 1. The value of limit x tends to 1 x cube minus 3x square plus 14x is 12 and the value of limit x tends to x raised to 6 minus x plus 1 equal to 3. Then 12 by 3 equal to 4. I hope you are understood my class. Thank you.